Hello, geometry classes. Let's figure out the answers to some volume questions. In this lesson, we're working with volumes of cones and pyramids. So, sample 1, what's the volume of the cone? We are given the diameter of the cone, 12 units. We're given this side length here of our cone. This side length here is 10 units. I like to call this the zipper length. That's different from the tent pole height. This is our H. And this is actually our slant height, so we have to figure out the actual height of this cone so that we can use the formula volume equals 1/3 pi r squared h. We're going to need to know that h. So let's take this triangle out here and let's figure out what that height is. So if we take it out, half of the diameter will be the radius 6. So that's 6. And then we are given the fact that the slant height is 10, and that's going to give us a chance to use the Pythagorean theorem to figure out the tent pole height. This is going to be our h, and I'm going to plug into the Pythagorean theorem, so we're going to call it a for right now. So that's a squared plus 6 squared equals 10 squared. And then I'm going to solve this for a. That's a squared plus 36 equals 100. Then I'm going to subtract 36 on both sides, and I'll have a squared equals 64. Taking the square root of both sides gives me a equals 8. So my height is 8. That's what my h is here. Now I can plug into my formula. So I have volume equals 1/3 times pi times, well, my radius is 6, so 6 squared, times my height of 8. So my h is 8. Simplifying that gives me volume equals 1/3 times pi times 6 squared is 36 times 8. And 1/3 of 36 is 12. So 12 times 8 times pi is what my volume will be. And then 12 times 8 is 96. So my volume will be 96 times pi. That's what I'm going to plug into my calculator. Of course, you could plug all this into your calculator if you don't want to simplify beforehand. However, if it's easy simplifying, I always recommend that you do that first. You're less likely to have errors plugging into your calculator that way. So volume is equal to 96 times 3.14. I am using the value of 3.14 for all of these problems because not everyone has a pi button on their calculator. All right, so that gives me 301.44 units cubed for the volume of this cone. All right, sample 2, we're not asked for the volume. We are given the volume of that pyramid, and this is a pyramid that's been pushed a little bit over. And so we're going to use the volume formula for a rectangular pyramid because that will work given Cavalieri's principle. We do need to know that perpendicular height between the point at the top of the pyramid and the base, and that's what we are asked to figure out here, that h. So we're going to figure it out based on the fact that the length and the width of the base here are 12 and 3. We also are given the information that the volume is 192 feet cubed, and from all of that we will calculate the height of the pyramid. Here's our formula. Volume for any pyramid or cone is 1/3 b times h. Our base is a rectangle. We will replace base with length times height. And then we'll plug all of our numbers into volume equals 1/3 times length times width times height. The volume that we're given is 192. That's equal to 1/3 times the length is 12, and the width is 3, and that's the length and width of the base that is a rectangle on the bottom of the pyramid. And then h is what we're trying to figure out, so we'll leave that a variable. Next step, I'm going to notice that the 1/3 and 3 completely cancel out, so I'm left with 192 is equal to 12h, and then dividing both sides by 12 will give me the height of that rectangular pyramid is 16 feet. All right, last sample. And this one we're asked for the volume, and we are given a cone that has a height of 18 centimeters from the base to the point at the top. And we're using Cavalieri's principle here because this has been tipped over a little bit, but as long as all those cross-section circles are congruent, which they are, then we are going to use the standard volume formula for a cone. So all of these circles inside would be, those cross-sectional circles on that cone would be the same as if it were a cone that were a right cone. So our formula will be volume is 1/3 bh. The base is a circle, so we'll rewrite the formula as volume is 1/3 times pi r squared h. Now plug our numbers in so we can find the volume, 1/3 times pi times our radius. We were told the diameter is 5 centimeters, so dividing 5 by 2 gives us 2.5. So we'll plug in 2.5 squared for our radius squared, and we're given the height is 18. Again, I'll do a little bit of simplifying before I plug this into my calculator. I know a third of 18 is 6, and I know 25 times 25 is 625. Putting the decimal point in will give me 6.25. And then it's easy for me to work out 6 times 6.25 is 37.50 pi. And then I'm going to plug that into my calculator, and my final result will be volume is 117.75 centimeters cubed. All right, it's time for you to move on to the quiz part of this lesson, and we'll see you next time.